Hi friends, welcome to our YouTube channel Raj Academy. The main aim of this lecture is to discuss about the AP Transco 2019 electrical solutions in a very detailed manner. If you are seeing this video lecture for the first time on our YouTube channel, then please do like, share and subscribe our YouTube channel, and don't forget to push the bell icon button so whenever we upload a new video, the direct notification comes to your mobile. If any improvements needed in our lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. So not to waste more time, so let's get started. So now we are going to solve the 21st question. See the question here. A 3-phase 4-wire 400 volt system is supplying a balanced star connected load with impedance of 10 angle of minus 300 degree ohm. So here they are given a 3-phase 4-wire system supply, and also the load impedance is same on each and every phase. So therefore this is called as a balanced load. And the voltages to neutral being 230.9 at an angle of minus 900 degree, and 230.9 at an angle of minus 300 degree, and 230.9 at an angle of minus 1500 degree. So they are given for the phase with the neutral voltages they have given, which VN, VBN and VCN voltage also they given. Now the current in the neutral wire is, so we need to figure out what is the amount of the current in the neutral wire we need to figure out. So out of the four options, option B, which is 0, is the correct solution of this question. So let's solve this numerical. So in the question they are given a balanced star connected load. Balanced star connected load is nothing but the impedance on the each and every phase is same, the magnitude and also the angle part. Then only we are going to say that is a balanced load. So here they are given a 3-phase, A, B, C, 3-phase and a 4-wire. That's another wire which is neutral wire. So we need to find, they have given the phase and the neutral voltage for each and every phase they have given, and also we need to find how much amount of the neutral current is flowing in this wire. We need to figure out. So what I am going to do is, now I am going to apply the KCL. See, the current in this branch is nothing but the current in this branch is voltage by impedance, and similarly the current in this branch is nothing but this, let me assume this I1, and this I2 is nothing but the voltage by impedance. I2 is VBN by Z, and similarly I3 is equal to VCN by Z, voltage by the impedance. So the sum of the incoming currents is equal to outgoing currents. The incoming currents are IA, I1, I2, I3 is equal to IN. So therefore here they are given VN is equal to 230.9 at an angle of minus 700 degree, VBN is equal to 230.9 at an angle of minus 300 degree, VCN is equal to 230.9 at an angle of minus 1500 degree, and the impedance that is nothing but 10 at an angle of minus 300 degree ohm. So by using the KCL, the outgoing current is equal to sum of the incoming currents, which is I1 is equal to VA1 by Z, I2 is equal to VBN by Z, and I3 is equal to VCN by Z. So now I have substituted the value of the VAN, VBN, VCN and also Z in this one. So now what I am going to do is, now here whenever the angle goes to the upper part, it will become negative. So therefore minus 900 plus 300 is nothing but minus 600. Similarly minus 300 minus of minus 300 is nothing but 0, and similarly minus 1500 minus of minus 300 is nothing but minus 200. I have just made this angle to the upper part. So therefore now I have taken the magnitude is a common on each and everything. So therefore I have taken the magnitude. Now it becomes 1 at an angle of minus 600, and 1 at an angle of 0, and 1 at an angle of minus 200 degree. So what I am going to do is, I am going to convert the 600 degree in terms of 360 plus 240. So therefore 600 is nothing but 240 degree, and similarly 200 degree is nothing but 360 into 3 plus 120. So therefore if you want minus 600, then you need to keep here minus. So therefore minus 600 is nothing but minus 240, and minus 200 is nothing but minus 120. So in place of minus 600 I have replaced minus 240, and also minus 200 I have replaced minus 120. So now it is in the clockwise. Clockwise is minus 240, the anti-clockwise it is nothing but 120 plus 120. So there I have replaced here plus 120, and similarly minus 120 is a clockwise. So in terms of the anti-clockwise it is nothing but plus 240. So therefore now we know the operator A is equal to 1 at an angle of 120, and A square is nothing but 1 at an angle of 240, and A cube is nothing but 1. So if we do this addition of these three vectors, we are going to get A plus A square plus A cube is equal to 0. So here this is nothing but A, this is nothing but A, this is A cube, sorry, this is A square. So A plus A square plus A cube is nothing but 0. So 0 into anything is also 0. So therefore neutral current is equal to 0 ampere is going to flow in this neutral wire. So now I am going to tell you a very shortcut method. By this shortcut method, you are going to solve this numerical in a very easy manner. So now I am going to tell a very shortcut method. By this shortcut method, you are going to get the answer in a very quick manner. So now, as you already know, the load is a balanced load because the impedance is at each and every phase is same. So now we are going to draw the vector diagram or phasor diagram of the supply voltages. So here VAN is equal to 230.9 at an angle of minus 900 degree. So therefore now 900 degree is nothing but 360 into 2 plus 180. So if you want the minus 900 is nothing but minus into minus, also keep minus. So therefore minus 900 is nothing but is equal to minus 180. So therefore minus 180 is nothing but this vector. So therefore this is the VN. This is the VN. Now we draw the phasor of the VN. Now VBN is equal to 230 at an angle of minus 300. 300 is minus 300 is nothing but in the clockwise it is plus 60. So therefore this is plus 60. This is plus 60 VBN. And similarly VCN is equal to 30.9 at an angle of minus 1500 is equal to 1500 degree is equal to 360 into 4 plus 60. So if you want minus, keep minus here also minus. So minus 60. So this is minus 60. So therefore this is angle total is 60. So VCN. So angle between VA and VBN is equal to 120. So therefore this is 120 angle. And similarly this is also 120. And similarly this is also 120. So if you see carefully, the magnitudes are also same and the phase difference between them is 120. So therefore this is called as a balanced supply. So whenever you give balanced supply to a balanced load, always the neutral current will be 0. If you give balanced supply means each magnitude has the same and also the phase angle between these two is equal to 180. Phase difference is nothing but 120. So therefore now whenever you give balanced supply to a balanced load, always the neutral current is 0. If you give balanced supply to an unbalanced load, always the neutral current is not equal to 0. It is non-zero. Whenever you give unbalanced supply to a balanced load, always the neutral current is equal to not equal to 0. And similarly, if unbalanced supply given to unbalanced load, always not equal to 0. But in our question, the question is going to satisfy this one. The supply is a balanced supply and also the load is a balanced load. So by default, always the neutral current will be 0. So by knowing this property also, we are going to solve this question in a very fraction of second, so that we can save our time to solve the remaining questions. So finally, the neutral current is nothing but 0 ampere. So now we are going to solve the 22nd question. See the question here. For a DC-DC converter, for a DC to DC boost converter circuit, the order of connection of the components L, C, D and the MOSFET switch in between the supply and the load from the left to right. So we need to figure out the connection of the inductor switch is nothing but a MOSFET switch, and the diode and the capacitor. So we need to find the type of the connection which is present of these components in a DC to DC boost converter, and from left to right we need to figure out. Left is nothing but a supply side and right is nothing but a load side. So we need to figure out the type of the connection of these components. So out of the four options, option C, it is L is in series, which is in parallel, and D is in series and C is in parallel. So let's solve this numerical. So in the question they asked only about the boost converter type of the connections. So let me explain for the each and every converter, and then we are going to discuss about the boost also. The first thing is the converters are of three types, which is buck converter and the boost converter and the buck boost converter. So the buck converter circuit is nothing but here this is the DC source and this is the load. For this load always we are going to connect a capacitor in parallel, because capacitor in parallel always reduce the amount of ripple in the output voltage. So capacitor is always placed in parallel with the load because it is going to reduce the ripple in the output voltage. So therefore now what we are going to do is we are going to connect the connection such manner. For the buck converter it is always here switch, and then it will be a diode in this fashion, and this is the inductor. So this is the basic connection of the buck converter. So based on this connection we are going to draw for the other circuit diagrams. So here always see carefully, this is nothing but switch, this is diode, and this is N. So now with this diagram now I am going to draw the boost converter. So boost converter is nothing but same SDL. So now you have to write from here SDL, same fashion. So now the switch is nothing but this one, the switch. This is diode is in the same this way, diode in this direction, and similarly this is the inductor. So always the capacitor is always in parallel with the low, because in order to reduce the ripple in the output voltage. So this is the connection of the boost converter based on the buck converter. Now I am going to draw the buck boost circuit diagram based on this one. So S is always same as the previous one, but we need to interchange these two things. Interchange these two things. That's it. So this is S. This is nothing but inductor, and this is now diode. Diode has to be reverse direction. So capacitor is always connected in the parallel. This is V0. So now this is the circuit diagram of the buck boost converter. So here always the switch is in the series, and the diode is in parallel to the load, and the inductor is again series with the load. So capacitor is again parallel with the load. So this is the connection of these components in the buck converter. But if you see here in the boost converter, switch is always in parallel, and diode is in series, and inductor is in series, and the capacitor is in parallel. So now switch is in series with the load, series, and the diode is in series, inductor is in parallel to the load, and the capacitor is also parallel to the load. So now we are going to study about the average voltage across the buck converter. Average voltage of buck converter is nothing but D into Vs, where D is called the duty ratio and Vs is the supply voltage. So always the D value lies between 0 to 1. So therefore V0 value also lies between 0 to Vs. So therefore this is called as the buck converter, is also called as a step down converter, because output voltage lies between 0 to Vs. But if you come to boost converter, the output voltage expression is nothing but Vs by 1 minus D. So as the D value lies between 0 to 1, V0 value is always greater than or equal to Vs. So therefore the output voltage is more than the supply voltage. So it is called as a boost converter, or also called as a step up converter. But if you come to buck boost converter, V0 average is equal to minus D, Vs by 1 minus D. So that we are going to get V0 output voltage less than or equal to 0 to Vs, and also lies between D greater than Vs. So we are going to get the two ranges of the previous one. This is called as a buck range, this is called as a boost range. So that's why it is called as a buck boost DC converter, DC to DC converter, because input voltage is DC and output voltage is also a DC waveform. So now these expressions are old only for the continuous current conduction, means the inductor current is always in a continuous conduction, which is not, means it is not going to have any zero for certain amount of duration. If the current is zero for a certain amount of duration, then it is called as a discontinuous conduction. Continuous conduction is nothing but there is no non-zero, there is no zero, always current is a continuous. That's why it is called as a current continuous. So these expressions are hold only when the current is a continuous, then these expressions will be hold. So now in the question they have asked only for the boost converter, the type of the connection of the components. So switch is in parallel, switch is nothing but a MOSFET, diode is in series fashion, and inductor is in series fashion, and the capacitor is in parallel. So therefore this is the correct solution of the question. So in any of the other competitive examinations, it has a high amount of chance to ask for the switch connectors in the buck boost and also the buck converter. That's why I have explained these two also in the along with this one. So this is the final solution of this question. So now we are going to solve the 23rd question. See the question here. In a DC to DC buck converter, when the MOSFET switch is triggered, the rate of change of current in the 400 microhenry inductor is 7.5 into 10 to the power of 4 ampere per second. If the converter is operated with a 50 volt input voltage, the output voltage of the converter is. So this is in the question they have told about the buck converter. Buck converter, in this buck converter, the inductor value also given, which is 400 microhenry. So whenever the MOSFET switch is on, the rate of change of the inductor current is nothing but 7.5 into 10 to the power of 4 ampere per second. So with this, they are given the input voltage is 50 volt. So we need to figure out what is the output voltage. So out of the four options, option B, which is 20 volt, is the correct solution of this question. So let's solve this numerical. This is the circuit diagram of the buck converter. So based on this buck converter, they are given the inductor value is nothing but 400 microhenry, and when the switch is on, the rate of change of inductor current is nothing but 7.5 into 10 to the power of 4 ampere per second, and the supply voltage is equal to 50 volt. So we need to find what is the output voltage, or it is also called as the average output voltage, or just output voltage we need to figure out in this question. So therefore when switch is on, so now I am going to draw the circuit at when switch is on. So when the switch is on, so I have replaced switch with the on condition. So therefore now this is supply voltage and this is the output voltage. So this is circuit diagram. See here, for a Diode, we are giving a reverse bias supplies. Reverse bias means N junction is supplied with positive polarity and the P junction is supplied with negative polarity. So therefore this is called is in a reverse bias condition. So therefore it acts as an open circuit. So therefore this is open circuit. So now the DC source is going to supply its energy to the inductor and inductor. So therefore inductor is going to get charged. So when the switch is on, the inductor is going to get charged, means the rate of change of means the inductor current is goes on increases. So the inductor current goes on increases. So therefore this is a fashion. When switch is on, the inductor current is goes on increases. Means it is in charging condition. So as they give, and now the voltage expression, this is nothing voltage across the inductor. So the voltage across the inductor is nothing but by KVL, supply voltage minus output voltage. So VL is equal to Vs minus V0. So VL is nothing but current into DL by dt. That is the basic concept of an inductor. So L into DIL by dt is equal to Vs minus V0 is equal to, in buck converter V0 is equal to dVs. So we know the value of L. L is nothing but 400 into 10 to the power of minus 6. DIL by dt is nothing but 7.5 10 to the power of 4. And Vs is nothing but 50. And D also Vs is equal to 50. There is only one equation with one unknown. D we need to figure out. So therefore, our solve the basic equation, we are going to get D is equal to 2 by 5. But we need output voltage. So V0 is equal to D into Vs. We know the value of D, just 2 by 5 into Vs is nothing but 50. So if you solve, we are going to get V0 is equal to 20 volt. So see here, whenever the switch is on, the current in the inductor goes on increases, means the current is in charging condition. But when the switch is off, suppose when the switch is open, means here now whatever the current it is going to, means the diode is going to now conduct. So whenever the diode is going to conduct, now what is going to happen is this inductor is going to deliver whatever the energy it is having, it is going to deliver to this load. Means the energy in this, at the time increases, the energy in this inductor is goes on decreases. So therefore the current is also going to decay. So therefore the current is also decreases in the whenever the switch is off. So whenever the switch is on, L is in the charging mode. So whenever the switch is off, L is in the discharging mode. So this is a linear fashion of the current change. Linear fashion, this is a linear way it is changing, and also linear way it is going decreasing. So finally the solution is nothing but V0 is equal to 20 volt is the correct solution of this question. So now we are going to solve the 24th question. See the question here. What will come in the place of the question mark in the following number series? So they are given a number series, we need to figure out what is the value in the question mark. So the series is nothing but 5, 14, 45, 130 and the question mark and the 1182. So that question mark we need to figure out. So out of the four options, option A, which is 397, is the correct solution of this question. So let's solve this numerical. So this is a number series they are given in a question. So we need to find this question mark. So if you see carefully here, 5, the relation between 5 and 14 we need to figure out. The first thing is here, 5 2s are 10 plus 4, or 5 3s are 15 minus 1. So therefore I am going to write here 5 into 3, 15 minus 1, you are going to get 14. And similarly, if you want the 45, you need to do 14 into 3. 14 3s is nothing but for the 12, 42. So 42 you need to add, in order to get 45 you need to add plus 3. So plus 3 is nothing but 45. Again, so 45 into 3 is nothing but 135, but we need only 130. So therefore again minus 5, 130. And similarly, if you see the fashion, minus plus minus, and these are the odd numbers 1, 3, 5. So the next number is 7, and they are same multiplication 3. So therefore now the next number is 130 into 3, 130 into 3. Again now plus 7. This number is nothing but 397. 397. Now the next number is 397 into 3. If plus means the next number is minus, minus odd number is 9. Then you are going to get 1182. So therefore the question mark is nothing but 397. So therefore the fashion is, first we need to do into 3, or first initially minus, and the second case is plus, and it goes on. Again you need to take here odd number. So this is a sequence. Into 3 minus, the first one is minus, again is plus, it goes on repeating in that fashion, and the next number is nothing but odd number you need to take. Sequence of odd number. So with this you are going to get the question mark is nothing but 397. This is the correct solution of this question. So now we are going to solve the 25th question. See the question here. If certain amount of money becomes 2,500 in a span of 5 years and 3,000 in a span of 7 years at a simple interest, then the principal amount is. See here they are given a certain amount of money. It become 2500 in 5 years and 3000 in 7 years. As simple interest, this problem belongs to simple interest. So we need to find what is the principal amount, means initial amount, how much is given, we need to figure out. So out of the 4 options, option C, which is 1250 is the correct solution of this question. So let's solve this numerical. So initial amount of P, the principal amount is P. Suppose the person A given to the person B, initially is given P amount of money at a percentage of R% annually. So therefore now for 5 years he received 2500 rupees. For 7 years he can receive 3000 rupees. So we need to find what is the principal amount. So this question is belong to simple interest. So therefore the final amount is equal to principal amount plus simple interest. Simple interest is nothing but R percentage of principal money for time duration T. So therefore P plus PRT by 100 is equal to P into 1 plus RT by 100. So this is the general expression between the amount received, principal amount, and the rate of interest and the time duration for the simple interest concept. So now with this equation we are going to solve the numerical. So the question they are given for 5 years he is going to receive 2500 rupees. So therefore 2500 rupees is equal to principal amount to 1 plus R we don't know, but T we know, 5 by 100. This is the first equation. But the second case, for 7 years he is going to receive 3000 rupees. So therefore 3000 rupees is equal to principal into 1 plus, in place of T I am going to substitute 7 R by 100. Now I am going to subtract 2 minus 1. So 2 minus 1. Finally I am going to get 500 is equal to 2R by 100. Therefore PR is equal to 25,000 rupees. 25,000. So therefore now I am going to substitute this in the equation 1. So equation is nothing but 2500 plus P plus 5PR by 100. So in place of PR I am going to substitute 25,000. So therefore there is only one equation with one unknown. So P is equal to 1250 rupees. So this is the final solution of this question. So now we are going to solve the 26th question. See the question here. In a college, the ratio number of arts graduate to science is 3:2. Means the ratio of arts graduate means arts graduate is to science graduate is nothing but 3:2. If 20% of art graduates and 25% of science graduate qualify for IAS, the percentage of non-qualifiers. So here the percentage of 20% from art graduate and 25% from science graduate are going to qualify for the IAS. So the remaining non-qualifiers, how much is the percentage we need to figure out. So out of the four options, option C, which is 78%, is the correct solution of this question. So let's solve this numerical. In the question they are given that arts graduates is to science graduates is 2:3. So then for the IAS examination from the arts students 20% are qualified. Similarly, for the IAS examination from the science graduates 25% are qualified. So we need to figure out how many non-qualifiers percentage. So therefore I am going to assume here arts and science. Individually I have written here. So here they are given 2:3. So let me assume 20 students and 30 students. Anyway, it is 2:3. So 20 students belong to arts and 30 students belong to science. So total is nothing but total students. Total students is nothing but 20 plus 30 is equal to 50. So total 50 students from arts and science. In the question they are given 20% of the arts are qualified. So the remaining 80% are non-qualified. NQ means non-qualified. And similarly from here 25% qualified for the examination, qualified, and the remaining 75% are non-qualified. So we have to figure how many non-qualifiers are there. So this is nothing but here this NQ is nothing but 80%. So 80 by 100 into 20, and this is also 75 by 100 into 30. So we have to find the total percentage non-qualifiers. So from here these many numbers are non-qualified. From here these many are non-qualifiers. So we need to add this up, and by division 50 we are going to get the percentage. So 80 into 20 by 100 plus 75 by 100 into 30. The total is how much? 50 students. We need percentage. So if you do 100, we are going to get 78%. So finally 78% are non-qualifiers from the both 20 students and 30 students. So 75% are non-qualified. So this is the correct solution of this question. So now we are going to solve the 27th question. See the question here. 2 glasses of equal volumes are respectively half and 3/4 filled with milk. They are then filled to the brim by adding water. Their contents are then poured into another vessel. What is the ratio of the milk to water in the vessel? So here given that two equal volumes of glasses are initially they have taken, and the first one is we need to fill half, and the second one is for 3 by 4 we need to fill with milk. So the remaining amount of volume we need to add by water, and if these two glasses are going to pour in another vessel, how much is the amount of the milk and water which is present in the new volume, new glass we need to figure out. So the ratio we need to figure out. So out of the four options, option D, which is 5:3 is the correct solution of this question. So let's solve this numerical. Now there are two glasses, two equal amount of glasses, means equal amount of volume. So therefore, initially, suppose let me assume the total capacity is volume V. Here also total volume capacity is nothing but V. So initially they have given for the first class, half of the volume is nothing but milk. So remaining half is nothing but water. So in the question they are given two equal glass vessels. Two equal glass vessels. So let me assume the volume is V for the first class, and similarly the volume is V for the second class. So initially they are given half of the glass is filled with milk, means V by 2 is nothing but milk. So remaining V by 2 is nothing but water. And similarly in the second case, 3 by 4th is nothing but milk. So the remaining V by 4th is nothing but water. So now these two are going to pour in another vessel. So therefore in this vessel we need to find out what is the ratio of the milk to water. So the milk is nothing but the combination of these two things, V by 2 plus 3V by 4 is the new milk, and similarly V by 2 plus V by 4 is nothing but water. So now we need to find the ratio. So therefore milk is to water. So therefore here V by 2 plus 3V by 4. So we need to do the ratio with the V by 2 plus V by 4. So V is a common. So therefore if you do this one, 1 by 2 plus 3 by 4 is to 1 by 2 plus 1 by 4. So finally we are going to get ratio 5:3. So 5:3 is the ratio of the milk to water in the new vessel. This is the final solution of this question. So now we are going to solve about 28th question. See the question here. In a silent pole synchronous motor, the developed reluctance torque attains the maximum value when the load angle in electrical degree is. So here they have given silent pole synchronous motor. So for this reluctance torque attains the maximum value at a load angle in electrical degrees, we need to figure out. So out of the four options, option B, which is 45 degrees, is the correct solution of this question. So let's solve this numerical. So in the question they have given silent pole. So actually the motors are two types, which are silent pole synchronous motor or cylindrical pole synchronous motor. So for the silent pole, the torque is developed is proportional to the sin 2 theta, and for cylindrical pole, the torque developed is directly proportional to the sin theta. So in the question they are given. So therefore, if you solve this one, suppose I am going to solve this one, silent pole. So dt by the maximum torque we need. So dt by t theta is equal to sin theta. If you do the differentiation, it will become cos 2 theta by t by 2. So now we need the maximum value. So at the maximum value, this differentiation will become 0. So therefore 0 is equal to cos theta by 2 0. So therefore cos 2 theta is equal to 0. So 0 is nothing but cos of 90. Cos 90 is 0. So therefore 2 theta is equal to 90 degree. So therefore theta is equal to 45 degree for the silent pole. For the silent pole, at an angle of 45 degree electrical angle, load angle, we are going to get the maximum developed torque. But for a cylindrical pole, torque is directly proportional to sin theta. It means here dt by dt is equal to, if it is a differentiation, sin is nothing but cos theta. So it's the maximum at cos theta is equal to, so at theta is equal to 90 degree, at theta is equal to 90 electrical degree, the cylindrical pole will have the maximum torque. But for silent pole synchronous motor, we need to have at 45 degrees. At 45 degrees there will be a maximum torque. So this is the relation between the silent pole and cylindrical pole. But in the question they asked only for silent pole. So therefore theta is equal to 45 is the correct solution of this question. So now we are going to solve the 29th question. See the question here. It is required to melt 3 tons of steel using an electric arc furnace. So by using electric arc furnace, we are going to melt the 3 tons of steel. The heat energy required to melt 1 kg of steel is approximately 170 kilocalorie. Means the heat energy which is required to melt 1 kg of steel, we need 170 kilocalories of heat energy it is required. So the electric power utilized by the furnace is 510 kilowatt. The time taken by the furnace is, so the total power which is drawn is nothing but 510 kilowatt. So we need to find, for to melt this amount of 3 tons of steel, how much time duration is taken by this electric furnace, we need to figure out. So out of the 4 options, option A is 1 hour 10 minutes is the correct solution of this question. So let's solve this numerical. See here, the power taken by the electric furnace is 510 kilowatt. So for 1 ton to melt, we need 170 kilocalories. Means 170 kilocalories of heat energy is required to melt 1 ton. So therefore 3 tons is nothing but by linear fashion. So if you multiply by 3, here also you have to multiply by 3. So for 3 tons, this much amount of kilocalorie is required to melt the 3 ton. So we need to figure out how much duration, how much time it takes to melt this 3 ton of steel. We need to figure out. So here 1 ton is nothing but 1000 kg. 1 ton is nothing but 1000 kg. And 1 calorie is equal to 4.2 joules. So this is a conversion from calories to joules. 1 calorie is nothing but 4.2 joules. So the basic formula is energy consumed is equal to power into time duration. So power is nothing but how much of energy is consumed for 1 second. So energy is equal to power into time. The unit of energy is nothing but joules. The unit of power is watt and the unit of time is second. So therefore the joules is equal to watt into second. So by this we are going to solve here. So energy is equal to power into time. So the total amount of energy is nothing but for melting 3 ton is 3 ton into 170 kilocalorie is equal to power is 510 kilowatt. So therefore 510 into 10 to the power of 3. This is time t. So now 3 ton is nothing but we need to convert from ton to kg. So 1 ton is equal to 1000. So therefore 3000 kg into 170 into kilo means 10 to the power of 3. 1 calorie is nothing but 4.2 joule. So therefore this total energy is in the terms of now joules. This total is in the form of joules. Means the energy is in the number of joules. And the power is 5 into 10 to the power of 3. So now it is in the term of watt. So therefore by that relation, so time will be in second. So therefore this is a t. So only equation with only one unknown. So therefore time is equal to, after solving this one we are going to get 4200 seconds. So we can write in this fashion, right? 3600 seconds plus 600 seconds. So for 1 minute 60 seconds. So for 10 minutes it will be 600 seconds. So for 60 minutes it will be 3600 seconds. So 60 minutes is nothing but 1 hour. So therefore 3600 seconds means 1 hour. 600 seconds means 10 minutes. So finally time duration is nothing but 1 hour 10 minutes. It is needed by the electric furnace to melt 3 ton of steel. It is required. So therefore the final solution is 1 hour plus 10 minutes. The duration is required. The last question of this lecture. So the question is the minimum number of 2 to 1 multiplexers required to realize an 8 to 1 multiplexer is. So we are asking how many 2 to 1 is required, how many 2 cross 1 marks are required to implement a 8 cross 1 marks. So out of the 4 options, option C, which is 7. 7 number of 2 cross 1 marks are required to implement the 8 cross 1 marks. So in the question again, number of 2 1 cross marks, the number of 2 cross 1 marks are required to implement a 8 cross 1 marks. So 8 cross 1 marks is also called as, it can be written in this fashion, 2 cube cross 1. So therefore 3 control signals are required for this one. So the general formula is, for implementation of, for the number of 2 cross 1 marks required to implement a 2 to the power of n cross 1 marks is nothing but 2 to the power of n minus 1. So in this fashion now n is equal to 3. So 2 cube minus 1 is equal to 7. So 7 number of, so total 7 number of 2 cross 1 marks required to implement a 8 cross 1 marks. So in another method also we are going to solve here. See here, the number of, so the general formula in this one is, suppose the number of n cross 1 marks required to implement n cross 1 marks is, here the number of n cross 1 marks required to implement n cross 1 marks. Here n is always greater than the m. So here the general fashion is, here highest number n by small number m, again n by m square, and again n by m cube, and it goes on. This is nothing but a quotient. Always you need to take the quotient. Suppose 8 by 7 by 2, the quotient is nothing but 3 and the remainder is 1. So 6 by 2, the quotient is 3 and the remainder is 0. But we need to take only the quotient value, this value, but not the remainder. So therefore the meaning of this bracket is quotient. So this formula is applicable only when the last one has a coefficient of, as a quotient of 1. Then only this formula is applicable. Otherwise this formula is not applicable. So see here, so 2 cross 1 8 cross 1 marks. The number of 2 cross 1 marks is required to 8 cross 1 is nothing but, so this is the fashion of m cross 1 and this is m cross 1. So m is equal to 8 by 2. 8 by 2 quotient is 4. Similarly again 8 by 2 square. 8 by 4 nothing but quotient is 2 and 8 by 2 cube means 8 by 8 quotient is 1. So 4 plus 2 plus 1 is nothing but 7. So total 2 cross 1 marks required to 8 cross 1 marks. So now I am going to draw the circuit diagram here. Circuit diagram is nothing but the first one represents 4. 4 means 4 number of marks 1, 2, 3, 4. Similarly the second one takes about 2 marks. So 2, 1, 2, 2 and the third one is 1. So 1. So this is circuit diagram. A, B, C. So A for the first box, for these two, second level, again B for each one control signal, and for D is the control signals. This is the C is the control signal. So I0, I1, I2, I3, I4, I5, I6, I7. So this is a circuit diagram of the, by implementation of 2 cross marks, each and every marks, we are going to implement a 8 cross 1 marks. So this is the circuit diagram, this one. So the truth table of this one is nothing but A, B, C. This is the truth table. For this combination, I0, I1, I2, I3, I4, I5, I6. So this total circuit is going to now implement like a 8 cross 1 marks. So this is the circuit diagram of the 8 cross 1 marks in terms of the 2 cross 1 marks. So finally the solution is nothing but 7. So by this lecture we have successfully completed the 30 questions of the AP Transco Electrical 2019 question paper in a very detailed manner, and the remaining questions will be discussed in the upcoming lectures in the same manner. So if you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button so whenever we upload a new video, the direct notifications comes to your mobile. If any improvements needed in our video lectures, then please do comment in the comment section. We will definitely include all those improvements in the coming lectures. And if you have any unsolved electrical question paper, then please do send us to the email address which is provided at the last of this lecture. We will definitely try our best to solve that unsolved question paper and produce that solutions in this channel. Thank you so much for watching this lecture. Keep smiling, take care and bye bye.